Welcome, friends, to my episode. Here, I think we shall start with the adaptations against changing thermal conditions. Right? Let's not waste our time, my dear friends. Let us jump on to the topic. So, friends, many plants have various means to guard against changes in thermal conditions. Friends, we have a very good topic. That should be covered in our following episodes. In one of our following episodes, we have to discuss the topic. That is nothing but the adaptations part. Adaptations means, friends. I have given a brief note, I think, regarding adaptations. Adaptations are nothing but the things or the abilities or capabilities that one develops to survive in the habitats which we generally are not used to. Okay, so that is called as adaptation in general terms, right? Coming back to our topic here. Many plants have various means to guard against changes in thermal conditions. And for instance, if you take the plants growing on the eastern side of a forest, which often suffers from night frosts. If we take example, the plants which are growing on the eastern side of a forest, which often suffer from night frosts, where the sun rays strike them early in the morning. Then just imagine, during night we have on the frosts, we have experience with the frost, and again early in the morning the sun rays strikes. So it is time for the plant to adapt for that sudden change. Experiencing frost during night, and again early in the morning, that has to adapt itself or change its abilities or things to experience that sun rays. Okay. Plants growing on the eastern side of a forest often suffer from night frosts, where sun rays strike them early in the morning. And as an adaptation against frost, okay, please try to understand. As an adaptation against frost, the starch changes into fat during autumn. Look, my dear friends, a beautiful and very surprising thing is happening here. The plants which are in the forest, and the two which are located on eastern side, where happens for them to experience night frosts and sunrays striking them early in the morning. See what happened. They adapted. They have taken up an adaptation against frost, which the plants are experiencing during nights. Here, adaptation is in the form where the starch changes into fat during autumn season. The fatty oil in the form of emulsion depresses the freezing point and increases the power of resistance to frost. A very beautiful thing is happening in the nature, my dear friends. It's beyond our imagination also. Of course, the realistic and the real-time physiological process that is operating in a plant body to adapt itself or to take up the tough situation or things that's happening in the nature. right? The fatty oil in the form of emulsion depresses the freezing point and increases the power of resistance to frost. A beautiful experience, right? Again, during winters, the insoluble organic reserves may transform into dissolved substances like the sugars, which depress the freezing point of plant tissues and thus prevent any lethal injury. Beautiful things we come across, my dear friends. Here during winters, the insoluble organic reserves may transform into dissolved substances like sugars, which depress the freezing point of plant tissues and thus preventing any injury, any lethal injury. That means in order to avoid or to prevent any injury which may be lethal to the plant, here insoluble organic reserves are transformed into dissolved sugars to depress the freezing point. So that is the way how they are escaping this kind of injuries which are lethal to them. Right. Presence of such substances like sugars, oil, and um, friends, while dealing with anatomy, generally we come, plant anatomy, we come across with various terms, with various substances that are produced and stored in various parts of a plant. And in that instance, we need to know about a substance called resin. Resin. These resins are produced by plants. Of course, they are having a different activity to perform. We need not go into detail what resins are literally mean. Okay, right. Presence of few substances like sugars, oil, and resinous bodies in the protoplasm greatly enhances the ability of cells to withstand extremes of temperature. That is, in order to withstand these extremities in temperature, we have few things like sugars, oils, and resins. These things they are present in the protoplasm. Basically, these things in protoplasm they generally enhance the ability of cells to withstand these kind of extremities in temperature. Right. Coming to excess of water in plant tissues that adversely affects the ability of plant to withstand extremes of temperature. I think you understand. When you find the water, the quantity of water, which is more than required for a plant, of course, to perform the photosynthesis and to perform various metabolic activities or physiological activities, etc. And the remaining part of water which is taken up in excess, even that has an adverse effects on plants' ability to withstand these kind of extremities of temperature, right? And of course, for this reason, the young shoots of temperature of temperate trees. The trees that are growing in temperate region. And again, I need to go back. I need to recall our earlier episode where we have some discussion regarding that tropical plants, subtropical plants, and temperate plants like that. And once again, I will tell that what temperate trees means. Here, my dear friends, temperate means It's a region basically a part of globe, it's a part of the globe that is being differentiated from the other region, wherein taking into consideration the particular climatic conditions that are present around, nearly up to 40 degrees latitudes, that may be northern or southern hemisphere, my dear friends. And that particular area may be considered as a temperate region where we find cold climates, and of course, the the influence of sun or temperature might be less when compared to subtropical and tropical regions, and that is what about temperate regions, right? Here, the trees that are growing in temperate regions, and if you take the um, young shoots, of those particular trees, here what happens means they contain plenty of water. They contain plenty of water and suffer from late frosts, but the older shoots are not damaged. See, my dear friends, we are talking about excess water in plants. Okay, right. The young shoots of temperate trees, which contain plenty of water, they suffer from late frosts, whereas the older shoots, they are not damaged. And similarly, the dry seeds, if you take the dry seeds, they can withstand a temperature. They can withstand a temperature as high as 100 degrees Celsius. But if they are soaked in water, they cannot endure temperature higher than 70 degrees centigrade. I think, friends, you got my point. We are dealing with the excess water present in plant body, wherein, of course, when we take the young shoots, which are having plenty of water, they are suffering from late frost, whereas the older shoots, generally, which they don't retain water, no, there you don't find any damage. And similarly, when dealing with the dry seeds, they can withstand the temperatures up to or more than 100 degrees Celsius. And when they're soaked in water, and they cannot withstand to a temperatures higher than 70 degrees Celsius. A very spectacular thing or wonderful thing that's happening. Generally, friends, while dealing with the subject in general, we don't come across these kind of facts or these kind of surprising things generally. It's very really surprising for me as a biologist also to know things like that. When dealing things with light or temperature in detail, and how they affect at different conditions or situations. It's very a beautiful experience for me to share these things with you, my dear friends. Right. In certain cases, plants develop special structures to protect their delicate organs against extremes of temperature. So, friends, we are dealing with the adaptations part, and in this context or in this connection, here we see a special thing, that is plants developing special structures to protect themselves, uh, to protect their delicate organs against these extremes of temperature. So, for example's sake, a number of Arctic and alpine plants have a grey cotton like hairy outgrowth. Here, for example, we are seeing, if you see, a number of Arctic and alpine plants have a grey cotton like hairy outgrowths. Once again, friends, we got a new term here, that is Arctic and Alpine. In one of my earlier episodes, my dear friends, while dividing the globe into various regions, I have used a term like subpolar and polar. So, talking about coming across with the word Arctic and Alpine. Of course, Alpine may be confined to subpolar regions, whereas Arctic means we are dealing with the exclusive polar region, my dear friends. Of course, we need not get confused. Why? Because even poles used to experience the growth of vegetation, my dear friends. Of course, with various kinds of adaptations, and of course, very few species which are having that capability or adaptability to live in that, or to sustain in that kind of habitat. Right. So, what's happening here means, if we consider the plants belonging to Arctic and alpine plants, they develop some kind of gray cotton like hairy outgrowths. Because in order to protect their delicate organs, and of course, buds are protected by bud scales and hairy envelope. Right, friends. Let us move on to effects of high temperatures. And moving ahead, my dear friends, the effects of high temperature are altogether different. Besides increasing the rate of transpiration and, of course, affecting the soil water contents, high temperature has certain other injurious effects, which may consequently result in the death of the plant also. Friends, if temperature rises above maximum limits, then what happens means the plant becomes inactive and may develop choruses. They may develop choruses. Keep the word choruses in mind, my dear friends. I'll explain in detail about that word in my following sessions. Right. If temperature rises above maximum limits, then plant becomes inactive and may develop choruses. Right. High temperatures generally tremendously increases the rate of respiration. High temperatures tremendously increases the rate of respiration. So what happens, my dear friends, when there happens an increase in the rate of respiration? Generally, the plant may die. The plant may die of starvation, because of starvation. Plants are variously adapted to withstand high temperatures, and plants growing in extremely warmer regions are usually succulent. Succulent means, my dear friends, you find generally xerophytic in nature. Succulent means the word itself, it implies that the plants having the leaves or stems which generally absorb the water and somewhat swollen like appearance you find, and those they are classified as succulents. Basically, they are xerophytes to a greater extent, and they have xerophytic habitat. They have xerophytic habitat, right? Plants growing in extremely warmer regions are usually succulents. Their leaves are very much reduced and stomata are sunken. You note this point, dear friends. plants which are growing in extremely warmer regions, which are generally branded as succulents. If you notice their leaves, they are very much reduced. And if you observe the stomata, they are sunken. Sunken means they're embedded in nature. Embedded in nature. Stomata are sunken and covered with hairy outgrowths. These are the adaptations, generally plants which take up a warmer habitat, right? And in general, the effects of temperature are more obvious when considered from the wider point of view of plant geography rather than only a plant ecology, right? Mm, Temperature normally does not affect the types of plant communities to be found in a particular area. Um, so much as it determines the species present in that area. Okay. Here we are going to discuss about the limits or limitations of atmospheric temperature. A temperature that is most supporting to reproduction, seed germination, growth and development is called optimum temperature. So friends, it is nothing but the optimum temperature which is supporting to the reproduction process, the seed germination, growth and developmental processes. We require optimum temperature levels. And life activities of other organisms are at their best during optimum temperature range. And however, organism can still survive, though with low efficiency at a temperature below or above. I mean to say it's a minimum or a maximum. Maximum to this optimum temperature. Most organisms tolerate temperatures that is ranging between 0 degrees Celsius to 50 degrees Celsius. Generally, 25 degrees Celsius, and of course, plus 5 or minus 5 maybe, is optimum for a large number of organisms. I once again come back, my dear friends. Generally, it is 25 degrees Celsius temperature. It is the optimum temperature for a large number of organisms. And depending upon the response of plants to temperature of environment, the entire vegetation of the earth can be divided into the following 4 classes. Depending upon the response of plants to temperature of an environment, the entire vegetation of the earth can be divided into following 4 classes. Number 1, the megatherms. Megatherms. So megatherms, plants which require more or less constant high temperatures throughout the year for their optimal growth and development. And examples: the dominant vegetation of tropical rainforests. Now, mesotherms. These plants are capable of enduring considerably lower temperature during some period of the year. Such as the winter months, and then followed by higher temperatures, such as summer seasons. Of course, many plants of tropical and subtropical regions of the world can be included in this class. That is mesotherms. And examples of vegetation of tropical deciduous forests. See friends, for megatherms we have example of tropical rainforests. The speciality of the flora or the species growing in tropical rainforests is that they are evergreen. They are evergreen. And the examples for mesotherms, which are tropical deciduous forests. So, friends, we need to know about the word tropical deciduous forests. It is clear for us tropical means the plants which are growing or which are habited to tropical regions of the globe. So, likewise, deciduous forests. Deciduous means, my dear friends, the plant they shed up their leaves in particular seasons or at particular times, and particularly the flora or the species which are growing in the forests and which are a deciduous type of nature, they used to shed down their leaves in particular seasons. So I think it is clear for you what the word tropical deciduous forest means. Okay, let's move on to microtherms. Plants of temperate regions of the earth. That means I already explained earlier. Temperate means anything around 40 degrees and above or in between. That is either northern hemisphere or southern hemisphere. That is generally called as temperate region. Okay. Plants of temperate regions of the earth. They need much lower temperatures for their growth and development. That is when compared to the plants that are growing in other regions, that may be equatorial, tropical, or subtropical, etc. In that context, the plants which are living in temperate regions of the earth, they need much lower temperatures for their particular growth and development processes. These plants are incapable of enduring high temperatures even for a few months of the year. They are incapable of experiencing, enduring means experiencing high temperatures even for a few months of the year. And of course, all the high latitude plants, up to about 3600 meters of the tropical and subtropical regions can also be included in this group. Of course, example is a mixed coniferous forest. And here one more word, my dear friends, it's a coniferous forest. Students or people generally having their backgrounds with life sciences, they can generally understand about this word coniferous forest, my dear friends. When dealing with the plant, dealing with plant kingdom, in the basic classification itself, we come across with two types of words, that is the gymnosperms as well as the angiosperms. So conifers or coniferous forests, these plants, the species which are classified as conifers, they have their origin from gymnosperms, my dear friends. Okay, Even the country like India, we have many coniferous trees or forests, which are generally confined to that Himalayan region. Okay, I think you can understand. Not only microtherms means the flora or species which are confined to temperate regions, whereas the vegetation that is present in higher altitudes of height, that is up to 3600 meters, which are present in tropical as well subtropical regions also. They are also considered as microtherms, and particularly this coniferous forests, my dear friends. Friends, I think I should conclude here, and let us continue this discussion with this thing, the effects of temperature on plants. So thank you so much, my dear friends. I think hope you all enjoyed this session. Let us continue our next session with hextotherms, right?